Hi guys, here we're taking a look at logarithmic functions. Logarithmic functions. Here we go. Definition of a log. A log is denoted by this notation right here. A log, we would call that base A. And the way it works is this. When you see a log written out, log base A of x, basically we're saying A to the y power equals x. It's kind of a circle. A to the y power equals x. Written like that. A to the y equals x. So the exponent to which the base A must be raised to give x. So basically when you see a log, like you're going to see stuff like, what's log base 2 of 32? They're asking you, what power would you raise 2 to get 32? Okay, that's what the log is saying. What power would you raise this base to get 32? Which would equal 5 in that case, by the way. So down here, for example, this says log base 10 of 100,000 is 5. And the reason that's true is because 10, base 10 to the fifth power is 100,000. Log base 2 of 8 is 3 because 2 to the third power is 8. The answer over here is the exponent. The answer to a log is the exponent. Log base 2 of 1/8 is negative 3 because 2 to the negative 3 power is 1/8. One more here. Log base 5 of s equals r because 5 to the r is s. So the answer to a log is an exponent. It's the inverse of an exponent, of an exponential. The last 2 days we did exponential functions. Log functions are basically inverses of the exponential functions. Okay, evaluate. They're going to give you something like this. And again, what that first one's saying right here, it's saying 10 to what power is 1,000? Well, the third power. 10 cubed is 1,000. So the answer is the exponent. Log base 2 of 32. 2 to what power is 32? The fifth power. 2 to the fifth is 32. The answer to a log is the exponent. Log base 10 of 0.1, meaning 10 to what power is 0.1? Well, 0.1 is really 1/10. So what would you do to 10 to make it flip to 1/10? You'd raise it to the negative power, -1 exponent. Log base 16 of 4. 16 to what power is 4? Well, the square root of 16 is 4, so I'm going to say it's the 1/2 power because bottom is the root, top is the power. Properties, these are huge. Make sure you get these down somewhere. Anything, no matter what the base is, if you have log base anything to the and 1, log base A of 1, log base 5 of 1, it always equals 0 because anything to the 0 power is 1. If you see the base is the same as the number beside the base, like log base A of A is 1, log base 2 of 2, 1, log base 3 of 3, 1, because anything to the first power is itself. Okay, when you raise a to the power of 1, you get a. Right here, log base a to the x equals x. Think about this for a second. This is one of my favorite properties, and I don't get why people don't get it. It's basically asking you, that little a right there, what power would you raise a to get a to the x? X. That's why it equals x. We must raise a to the power of x to get a to the x. That's so hard for people sometimes. This is a weird one. A to the log base a of x power equals x. Log base a of x is the power to which a must be raised to get x. Okay, so if you want to get x, and you're going to raise a to some power and get x, remember, a log is the inverse of an exponent. Basically, gosh, I can't say this out loud. I'm going to whisper it. Because they're inverses, they give you x. Okay, remember doing this like f of f -1, that always equaled x. Or f of -1 of f equals x. It always equals x. So whatever's here is going to be what that equals every single time. Okay, let's try some here. This first one says log base 5 of 1. That has to be 0 because anything to the 0 power is 1. The next one, log base 5 of 5. First power, because 5 to the first power is 5. Next one, log base 5. This is my favorite one. Log base 5 of 5 to the 8. So it's asking you, what power would you raise 5 to get 5 to the 8th power? 8, duh. I hope it's duh. There's supposed to be a little 5 written in here. Put a little 5 right there. There you go, log base 5. Okay, 5 to the log base 5 to a power. Again, remember, a log is the inverse of an exponent. So it's the same thing as doing this again. Okay, so when you do inverses, they don't cancel, but they do. Okay, so you just get 12. You just get 12. That's the property that we saw on the last slide. All right, common log. Common log means it's base 10. So what's just going to happen to you sometimes, you're going to see a log just written like this, like just log x. Anytime you see a log and there's no base written there, it's understood to be base 10. Okay, so it's called a common log, base 10. If you don't see a base written there, it's base 10. Natural log is base E. So if you see ln, I know it's natural log, but we put ln, log natural for some reason. Anyway, natural log x, that means this. Same thing as log base E. So they're not ever going to write base E, but anytime you see natural log, you see ln, automatically that's base E. Just like if you see just log and there's no base, it's base 10. So if you see this, natural log of x equals y, that means it's really, remember it's base E, e to the y equals x, that same circle pattern, e to the y equals x. It's written right there. Properties. Guys, the same properties that work with log work with ln. If you have natural log 1, it's 0 because anything, even e to the 0 power is 1. If you have natural log e, that really means this, means base e of e. E to what power is e? The first power. That's what it says right there. If it says natural log e to the x, it's basically this. It's basically saying e to what power is e to the x? Hello, x is. And this one, just like the last property we did last time, if you see e and it has an exponent of a natural log, that means the base is e, even though it's not written there. X, again, they're inverses. Again, it's just x. And natural log x is the power to which e must raise to get x. Okay, so hope that makes some sense. One more slide. Okay, evaluate. These are all calculator problems. Again, you need to find this button. If you found the E button yesterday on the calculator, then this is the natural log button without hitting. Actually, the first one we don't even need it. We don't need a calculator for any of these. That's 8 because it's asking you, remember the base on a natural log is E? So it's asking you e to what power is e to the 8th. Please get that one right. Okay, this one, natural log 1 over e squared. Notice the e's on the bottom. It's been flipped. So it means it's got to be negative. And because it's on the bottom and it's squared, it's got to be negative 2. So again, there's really a base e right there. Okay, e to what power is this? Well, you'd have to flip the e and square the e. That does that. That's what remember, the exponent is the answer to a log. And this one, natural log 5, don't know that one, just going to punch that straight in. My calculator hit the natural log button, 1.60944, and there you go. Hope that makes some sense. You did, I'll be honest with you, you did logs in Algebra 2. It's been a while since we've done them, and hopefully that's a good little review for you. We'll work on it tomorrow like we always do, and I'll see you then.